Okay, so this is chapter 6. This is our fingerprints notes. So let's get started. And as always, in our notes, we have our unit objectives. So we are going to talk about the history of fingerprints, basic characteristics, how compare and contrast, right? So that's going to have to do with how we are identifying and comparing fingerprints, and evidence reliability with fingerprints, proper procedures, um, identification technologies, and recorded fingerprints, lifting prints, and our FBI 10 cards, and ridge patterns. So those are going to be like the little fine details of a fingerprint. So vocabulary for the unit. And again, all vocabulary, we're going to have a Quizlet. So these are the basic vocabulary words. So these are the ones that you absolutely need to know. I mean, there's other words that are going to come into play, but these are the ones that are the important words for the unit. All right, let's start with our introduction. So our first kind of mention of fingerprints in literature goes back to 1894 with Pudd'nhead Wilson. And this goes from Mark Twain. And his signature, right, is he called it a physiological autograph. So this was before we really had fingerprints as fingerprint evidence. So Twain was really ahead of his time. But ancient cultures used fingerprints as personal markings, right? As early as, 1792, 1750 BC, fingerprints were pressed into clay tablets as contracts, right? They didn't necessarily have like a signature like we do now with our electronic signature pads. So they just basically did like a big thumbprint in, I think I went ahead too quickly. Sorry about that. Oops, nope, I didn't. Okay. And then we have 1684, we have Dr. Grew described the patterns he saw in human hands under a microscope. Right? This was a time period where science was booming, right? A lot of microscopic things coming into view by the invention of microscopes. And fingerprints being unique to each individual really came about in the later 1700s. And then in the early 1800s, we have 9 distinct fingerprint patterns described. And in our mid 1800s, right, we began collecting fingerprints, right, Sir William Herschel. In our later 1800s, right, we have the Bertillon. So Bertillon not only worked with identifying fingerprints, but also different measurements based on bone structure. And in our late 1800s again, right, so we have this big boom of science, right, during this time period. Francis Galton verified that fingerprints do not change with age. All right, so interesting enough, your fingerprints have not changed since they were formed, and we'll talk about how they are formed a little bit later. And in our latest 1800s, right, 1890s, we have a system that divided fingerprint records into groups. And this is the basis of what we call a 10 card, right? 10 fingers, 10 card. All right, so here we just have an image of right here. We can see that there's a fingerprint imprint in a clay tablet from a very long time ago, ancient seal, contract. So now here we have, this is what's called an FBI time card. All of this, information would be filled out. And then this is where they take each of the fingerprints, and then also a hand print as well. All right, so in 2012, the FBI maintained what we call the APHIS system, which is, you might have seen that mentioned in, forensic files, or you might have heard it mentioned in like CSI type of shows. So this is basically computerized fingerprints, right? So they're scanned and recorded, and they are compared. And then now in 2013, the FBI was integrating this ability to compare crime scene palm prints with prints collected at the time of arrest, right? 20 to 30% of prints, right, latent prints, right, those are the ones that are not visible to the eye, but then are dusted or revealed chemically, come from the palm, right? So then the palm of your hand, or the side of your hand, right, from your pinky finger to the wrist, right? So that's usually from pressure and leaning on the hand. So having a way to identify that type of print is very important. It's going to help us narrow down a crime scene. All right, fingerprints are formed, and this is important to know, the 10th week of gestation. So what does that mean? That means in utero, so as a fetus is being formed, right, in the 10th week is when we have fingerprints. And that happens because of how the amniotic fluid moves across the skin, the developing skin. And that happens in the basal layer of skin, which is really deep down in the skin. And then the fingerprints are then protected by the outer layer. So, right, what you feel on your skin is the outer layer. That's your epidermis, right? And your fingerprints are protected by that epidermis, right? The outer layer of your skin is not where your fingerprints are. Your fingerprints actually go pretty deep down. All right, so here's kind of a, diagram of what your skin looks like. Right, you have your pores, right? This is your skin surface. And then you have your epidermis, which is the protective layer. You've got your sweat glands right here, your sweat and your oil glands. And then now all the way down here, you've got your subcutaneous tissue, right? This is going to be down here where the basal layer is going to be. So there's three basic fingerprint ridge patterns, right? So there's basically three fingerprint general larger categories. We have the arch category, which accounts for only 5% of the population, right? That's a small number. We have our whorl, right? So whorl. And then we have what's called a loop, right? So 65% of the population has a loop pattern to their fingerprints. Then the next common would be our whorl and then our arch. So let's take a look at these a little bit. So an arch, right, we kind of go up and in and out, right, an arch. So now notice how we go, we have fingerprints enter and exit. Now let's look at this whorl. We have fingerprints enter, we whirl around and exit. And now loops, we whirl in and out. Okay, so those are some ways to investigate. And, some are easier to identify than others. These are pretty easily identifiable between an arch, a whorl, and a loop, but sometimes depending if it's a full print or a partial print, it becomes more difficult. So in our fingerprint, we have something that's called a core, right? A core of anything is going to be the center. And then we have something that's called a delta, right? So this delta is this little triangular area of a fingerprint. And now we have something called the ridge count, right? So ridges are these lines in a fingerprint. And the ridge count is something that is used to help identify matching fingerprints, right? Because it's kind of a characteristic from the core to the center of the delta. And I believe this one maybe has 5. So let's count. So from the core, we have 1 ridge, 2, 3, 4. And I think it's going to be 4. So 1, 2, 3, 4, 5. Yes, I forgot to count this first one right here the first time. So from our core to, let's go back. Sorry. Get a little click happy. From our core to this delta, right? The delta is this triangular area. We're going to talk about about that later. There are 5 ridges. So the ridge count on this print is going to be 5, right? That's an important characteristic when we start examining the small details of fingerprints. So now let's talk more about that little triangular area called the delta, right? Delta, the Greek letter delta, my drawing tools aren't working. So delta means triangle, right? The Greek letter. So here, this is a whorl, right? So you can see how it whirls around. So there's a delta here, this triangular area here. You see this little triangle pattern here. So there's 2 deltas in this whorl. And now here we have something called a central pocket loop whorl, right? So we go enter, we have this central loop pocket here, and we have a delta here and here. So the 2 deltas are not exactly on either side, right? It's a little bit offset. So central pocket whorls are a subset of a whorl pattern. And now we have something called a double loop whorl, right? So we have this whole like looping, right? And so we see this kind of double like yin yang symbol kind of thing, right? And we have 2 deltas. We've got a delta here and we've got a delta here. And now we have the most rare form of fingerprint, which is called the accidental whorl. And in an accidental whorl, we have 3 triangular areas, right? So those 3 deltas. So the deltas are really important for us to help figure out not only the type of fingerprint, but a subset of a type, right? Because these are all whorls, but we have a plain, a central pocket, a double loop, and an accidental. And it's examining the delta that's going to make or break how you identify the type of whorl. So now let's look at figure 6.8 and let's look at these types of arches, right? Remember, an arch goes in and out, and there's no swirl pattern, no circular pattern in the center. So here we have no deltas in an arch pattern. A tented arch just means a really steep arch that just goes up and down, and we can kind of sort of call this a delta. It's kind of like a smaller triangle in the center. So we have three types of fingerprints: patent, plastic, and latent. All right, these three terms are very important vocabulary terms. And a patent print, right? Here we have latent prints on a soft drink can. So if you can't see the print on the can, it's going to be a latent print. And we have to use methods to develop that print, like dusting it or revealing it chemically. Plastic fingerprints are things that are left like impressions, like that clay tablet. And then patent fingerprints are fingerprints that are going to be visible, but not imprinted into something else. So now let's take a look at, these are what we call minutia, right? So minutia just means really, really small things. So once we take a look at and we really expand a fingerprint, all of the little details, all of those lines, right, can be characteristic of an individual. And so ridge endings, so that means this is a line that stops. That's a ridge ending. Line that stops, line that stops. So these are ridge endings, right? Remember, ridges are the lines of the fingerprint, right? All of these make ridges. So now we have something here. Now see how this goes off, like it's like a road that branches, right? So we call that a fork or a bifurcation, right? The prefix bi means two, right? So when I split into these two different roadways, right? So I have this ridge and it stops and it goes in two different directions, a fork. Now we have an island, right? So between two ridges, if I've got this, smaller line, we call that an island. But now I have this. What's the difference between these two? Well, this is an island, and I call this one a dot. So a dot is just a very, very small island, right? So an island is a very small ridge, and a dot is an even smaller little itty-bitty ridge between ridges. So now we have what we call a bridge. So here I've got this two roads, and now I've got something that crosses between the two roads. So that's a bridge. And now this we call this either a spur or a hook, right? Not exactly a fork, right? So because it's not a, big split, it's just kind of like a little jaunt off of the main ridge. So we call that a hook or a spur. This, if I have like this loop, right? If I go in and I've got this circular area, we call that an eye. We're not going to call that an island, right? We're going to leave island for this one up here. So now we've got a double bifurcation, right? So double bifurcation. So bi means two and double means, so that would be like four, right? So I've got 1, 2, 3, 4 different directions. And delta, right, is going to be this triangular area right in the center here. And this would be a trifurcation because tri means 3, right? A tricycle has 3. So I've got this ridge and it branches off into 3 separate directions. So every fingerprint has all of these little itty-bitty little characteristics. And all of these little itty-bitty characteristics of your fingerprint is what makes your fingerprint unique to you and only you. Remember, even identical twins, although they have identical DNA, do not have identical fingerprints because of how the amniotic fluid flows across the skin as the fetus is developing. Okay, so can fingerprints be altered or disguised? And then how reliable are fingerprints? And how are they analyzed? And then how are we collecting latent fingerprints? So fingerprints can be altered or disguised, but only temporarily. Reliable fingerprinting is a means of identification. So fingerprints are a pretty good source of identification if you have a good print and if there are prints on file. If you only have a partial print and you have no partial files, no other files to compare it to, then a fingerprint really isn't going to be as helpful. And then how are they analyzed? And then how are we going to collect them? So here we have a technician, right? And he's examining 2 fingerprints by eye. So now the computer is really going to be doing the matching in general. We usually do not have technicians examining them by eye. I mean, you can narrow down being like, yeah, there's no way these 2 are together, right? Because look at how rural this is, and you don't really see that rural over here. But that doesn't mean, right? We want the computer to do the identification because those logarithms are extremely detailed. All right, so a crime scene analyst, right, uses a dusting powder and tape to collect fingerprints, right? Cars, right, the windows and the the metal and the plastic of cars are a great place to collect fingerprints. Police officers often, as on a traffic stop, will touch the back of a car to leave their fingerprints on the car in a traffic stop. These are the chemical ways that we can develop fingerprints, right? So we have something called an anhydrine, which is a spray, and that is going to be used when we're trying to develop fingerprints that are on paper, because not every surface is going to use the same way to develop fingerprints. And so what does that do? That reacts with the amino acids from your skin, and you're going to get like a blue-purple print when you develop this way. And then there's something called cyanoacrylate vapor. That sounds really fancy. That's basically that's super glue. Super glue is the chemical cyanoacrylate is the chemical that makes up super glue. And if you have something like plastic, metal, or glass, you can, or even skin for that matter, you can put those things in a chamber with some heat and some super glue, and then the fingerprint will get revealed as a white print, again, because reacting with the amino acids in your skin. If you are trying to collect a fingerprint off of wood or a piece of styrofoam, we would use silver nitrate, which is a chemical compound. And then you're going to be able to dip that or spray the object in question, and you're going to end up with a black or reddish brown, and you're going to need a little bit of ultraviolet light to reveal that print. And then we can also do what's called iodine fuming. So then that means iodine goes from a solid to a gas, right? It's called sublimation. And it goes from a solid to a gas, and it kind of emits some purple brownish vapors, and that reacts with carbohydrates, right? So remember, if you remember from Living Environment, iodine reacts with carbohydrates, and it's going to reveal some brownish, and it's going to end up fading. That's not going to be a permanent print that you can really see. Whereas anhydrine and the cyanoacrylate are going to leave prints that you're going to be able to use for a long time. The iodine is going to end up deteriorating. It's going to kind of deteriorate over time. All right, fingerprints can be scanned, and we have fingerprint powders, which we'll use in class to dust for fingerprints. And those fingerprint powders have nanoparticles, right? So particles that are super, super small, right? Nano means really, really small. And they're added to those fingerprint powders, and then they make pore patterns, right? So if you have a pattern of fingerprint and it's not really very clear, those powders are going to make those fingerprints appear even sharper, which is going to enhance the ability of those scans and of making a match. The materials that we touch always leave a trace. No matter how lightly we touch, obviously if you're touching with a firmer touch, you're going to leave like a much better fingerprint. But even a light touch of a fingerprint or a hand or even a foot is going to leave an indelible impression on any of the objects that we touch. So this is a high resolution image, right? All of these these are our ridges, and all of these little open spots, these are the pores, right? So you've seen your hands have sweat before, or your hands have gotten all clammy, right? So these are the pores, and that's where the sweat comes from, out of your pores, and the oils as well. We have a fingerprint here developed on a document from Leonardo da Vinci. All right, so this is just our summary. You're right. Humans have noticed patterns on their hands for thousands of years. Those used to be used for contracts and we go into our 1800s, and a lot of study has gone into the microscopic world in the 1800s and developing of fingerprints. And the elevated regions in your fingerprint are called friction ridges, right? Those little ridges on your hands, right? Those things allow us to grip. It gives humans an evolutionary advantage. We don't have smooth fingers. They may feel smooth, but those are little friction, and they're very sensitive. Right? If you've ever gotten like a cut or something on your finger, they can hurt a lot because there's a lot of nerve endings as well. And so we have our three basic categories, our whorls and our loops and our arches, right? Our whorls are very circular and have deltas, 2 deltas. And then our loops usually going to have 1 delta. They're going to go in one side and out the same side, right? A whorl goes in one side and out the other side, but swirls in the middle. And then you've got your arches, which go in one side and out the other side with no deltas, right? They all have a core, and we can use that core to a delta to calculate our ridge pattern. And then please remember 10 weeks gestation, right? So that is from conception, 10 weeks, right? Just about 2.5 months later, right? 2.5 out of the 9-month development, you're going to have individual fingerprints are formed in the womb. And they do not change over a person's lifetime. They can be slightly altered, right? If you have, scars on your hands, right? Those that actually become part of your fingerprints. Not even identical twins have identical fingerprints. Fingerprints left on an object are created by the ridges, right? Those in the secretions from the sweat glands, those amino acids and those oils. And when they're pressed against those objects, and those residues leave an impression. So we have our patent, our visible fingerprints. So that could be a fingerprint that you see in paint or a fingerprint from blood. A plastic fingerprint is an indentation, such as like in clay or in slime or putty or soil, I guess, for that matter. And then we have our latent. Those are the ones that are not visible to the unaided eye. So we can either use like ultraviolet light, dusting powders, and tape to lift those fingerprints. And remember, fingerprints are characterized as loops, whorls, or arches, and are compared on the basis of their minutiae, right? So the bifurcations, the islands, the dots, the ridge endings. And then criminals have sought to alter their fingerprints with chemical surgery and superficial destruction. Some fingerprints can be temporarily altered, but successful permanent fingerprint alteration, not altercation, have not been successful. Remember, it's only temporary because those fingerprints are formed so deep down in the basal layer of your skin that when you alter the surface, that the skin is going to end up growing back. Mistakes have led to wrongful convictions. But new forensic standards are constantly being developed, right? So a conviction based just on fingerprint evidence alone, right? We want to have as much evidence as possible to hold up in court. If you have a fingerprint and a DNA match, that's a great amount of scientific evidence. But again, the Innocence Project is going to work on things like that. We have our AFIS, right, which is our computerized system, which stands for Integrated Automated Fingerprint Identification System, right? It's a national database, right? So all countries have their own database, and different countries have different levels of what is an acceptable number of minutia matches. Fingerprints can be collected by dusting with special powders, right? You can do this at home. You can also do with cocoa powder, baby powder, talcum powder, or even cornstarch. And then lifting them on tape. You can use pencil lead or ink and Sharpies. Or we can also use certain chemicals, right? The super glue, which is the cyanoacrylate fuming. There are methods to do that at home as well. And hopefully we get a chance to do those in class. All right, so that is it for our fingerprint notes. And we will spend some more time talking about the minutia and the different types of fingerprints in another lesson.